Hello there, and welcome to the Sleepy Space Channel. The speed of light is one of the most stubborn limits in all of nature, and yet it holds a quiet loophole. Nothing may move through space faster than light, but space itself is under no such rule. Space can stretch as fast as it likes, and it does, carrying distant galaxies apart faster than any beam of light could ever close the gap. Every real dream of faster-than-light travel begins by trying to borrow that one loophole and aim it around a single ship. Tonight we follow that hope, from the cosmic scale all the way down to its stubborn, fascinating wall. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is a problem you need to solve. There is nothing here you have to follow closely. Settle in and let the question grow soft. Let your shoulders loosen. Let your breathing slow. Let the day fade gently away. Let's begin. There is a dream that returns again and again, older than any spacecraft we have ever built. It is the dream of crossing the enormous distances between the stars, not in lifetimes, but in an afternoon. Every few seasons, a version of this dream surfaces in the form of a headline. Someone, somewhere, has supposedly found a real way to travel faster than light. The words change a little each time. A new warp drive. A new equation. A new design that needs no impossible fuel. But the promise underneath stays the same, and it is a strange and quietly unsettling promise, because the speed of light is not merely fast. It is the speed the universe seems to have chosen as its limit, the one number that nothing is supposed to beat. Tonight, we follow that dream all the way down, slowly and without any hurry. We will look at what was actually shown, what the mathematics actually requires, and what the words faster than light actually mean. These three things tend to blur together in a headline, and untangling them is the quiet work of this whole journey. Most of these stories begin with something real. They trace back to genuine pieces of physics, written carefully, resting on equations that have held up for a very long time. The science underneath is usually sound. What gets lost, somewhere between the equation and the headline, is the fine print. And in this subject, the fine print is the entire story. The honest answer to the question in the title is no. No one has found a working way to travel faster than light. But the reason why is far more interesting than the dream itself, and far more peaceful. The limit is not a wall that the universe built to keep us out. It is something woven into the order of things, and by the end of this journey, it may feel less like a barrier and more like a kind of quiet. To understand any of this, we begin with the limit itself. Before we can ask whether anyone has found a way around the speed of light, we have to understand why the speed of light is a limit at all. It is one of the strangest facts in all of science, and one of the most steady. The speed of light is often described in numbers, but numbers are not where its meaning lives. Light crosses the gap between the Earth and the Moon in a little over 1 second. It reaches us from the Sun in about 8 minutes. These distances feel large to us, and the speed feels swift. Yet the truly important thing about the speed of light is not how quickly it moves. It is that it cannot be exceeded by anything, anywhere. That single rule shapes the entire universe we live in. It sets how long news can take to cross a galaxy. It decides which stars we could ever hope to reach. It quietly governs the size of everything and the patience that any journey through space would demand. So we begin there, at the edge of the limit, and we let the rest of the night unfold from it. It is worth remembering how old this longing truly is. Long before there were rockets, there were people who looked up at the points of light scattered across the night and wondered how far away they were. The honest answer, once it was finally measured, was almost too large to feel. The stars were not lamps hung just out of reach. They were other suns, set at distances so great that the numbers stopped meaning anything to the body. And so the longing changed shape, but never faded. If the stars were that far, then surely there must be a way to shorten the road. Surely the universe would not place such marvels in view and then make them forever unreachable. That hope is the quiet engine behind every faster-than-light headline, and it is a deeply human hope, worth treating with kindness rather than mockery. The pattern repeats with a certain rhythm. A piece of careful research appears, describing some new wrinkle in the mathematics of space and time. The wrinkle is real, and it is interesting, and in the hands of a headline, it becomes a promise it was never meant to make. A season later, the correction arrives, quieter than the claim. And then, after a while, the cycle begins again. There is no need to be cynical about this, and no need to be credulous either. The right posture is somewhere gentler, the patience of someone who has seen the cycle before and is content to wait for the fine print. The science is usually honest. The summary is usually too eager. The truth, almost always, is more interesting than either. This video is an attempt to sit inside that patience for a couple of hours. We will not rush to a verdict, and we will not pretend the verdict is more thrilling than it is. We will simply follow the idea down, carefully and calmly, until the question comes apart in our hands and shows us what it was really made of. The longing to cross the stars is not foolish. It is one of the most beautiful things our species has ever felt. But the universe answered it long ago, in a language of limits and distances, and that answer turns out to be its own kind of gift, if we are willing to listen to it slowly. There is a question worth setting beside the obvious one tonight. We ask whether anyone has found a way to cross the speed of light. But it is also worth asking what we are really longing for when we ask it. Underneath the wish for speed is a wish for nearness, a wish for the marvels of the universe to be less alone, less out of reach, more a part of the world we can touch. That wish is gentle and good, and the universe does not exactly refuse it. It answers in a different language than we expected, the language of limits and patience and enormous, unhurried distance. The stars do not come closer for our asking. But the reason they stay far turns out to be the same reason there is a steady, orderly cosmos in which to wonder about them at all. So tonight is not really a story of disappointment, though it ends with a no. It is closer to a slow walk around a thing we wanted, until we understand it well enough to set it down without sorrow. The dream loses none of its beauty by being understood. If anything, it grows quieter and more durable, the way a longing does once we have made peace with it. It may help, before we go further, to set aside the urgency that headlines carry and to move at the pace of the subject itself. The universe is in no hurry, and neither are we tonight. The distances have been what they are for billions of years, and the limit has held just as long. There is time enough to take the question apart slowly, and to find, at its center, something steadier than excitement. What we are really doing is learning the shape of a boundary. And a boundary, understood well, is not a frustration but a kind of map. It tells us where the universe holds firm and where it bends, where the doors are sealed and where the quiet windows lie. By the end of the night, we will have traced that boundary all the way around and found it whole. Many of the most lasting discoveries in science were not new ways to do a thing, but clear understandings of why a thing cannot be done. the conservation laws that forbid perpetual motion, the limits that forbid perfect efficiency. Each began as a disappointment and matured into a foundation. The speed of light belongs to that family, and tonight we are simply coming to know one more of the universe's quiet, load-bearing refusals. For now, there is nothing you need to solve and nothing you need to carry. The stars will stay where they are. The distances will hold. Let the question rest gently in the back of your mind, and let us begin to take it apart, one calm piece at a time. The speed of light has a property that sets it apart from every other speed in the world. It is the same for everyone, no matter how they are moving. This sounds like a small thing when it is said plainly. It is, in truth, one of the most surprising facts ever discovered about reality. Consider an ordinary speed first. If you stand still and watch a thrown ball, it moves at a certain pace. If you run alongside the ball in the same direction, it appears to move more slowly relative to you. If you run toward it, it appears to move faster. This is how every speed in daily life behaves. Motion is relative, and how fast something seems to move depends on how you yourself are moving. Light refuses to play by this rule. If you chase a beam of light, you do not gain on it, not even slightly. It still retreats from you at exactly the same speed it would if you were standing perfectly still. You could run at almost the speed of light yourself, and the beam ahead of you would still pull away at the full speed of light, as though your own great speed counted for nothing. This refusal seems impossible at first, and for a long time it puzzled everyone who studied it. The resolution, when it came, was stranger than the puzzle. If the speed of light is always the same, then the things we assumed were fixed, the very flow of time and the very length of space, cannot be fixed at all. They must bend so that the speed of light can stay the same for all. A clock that moves quickly ticks more slowly than a clock at rest. This is not a fault in the clock. Time itself runs slower for the thing that is moving. The faster it goes, the slower its time flows, measured against the world it is passing. This effect is small at everyday speeds and grows enormous as you approach the speed of light. A length that moves quickly grows shorter along its direction of travel. A passing object is genuinely compressed in the direction it moves, again not as an illusion, but as a real feature of space measured from outside. The faster the motion, the greater the shortening, until near the speed of light, lengths shrink toward almost nothing. Even the idea of two things happening at the same moment comes apart. Two events that appear simultaneous to one observer can appear to happen one after another to someone moving differently. There is no single universal now that everyone shares. Each observer carries their own slicing of past and future, and the slices do not all agree. All of this strangeness exists for one reason. It is the price the universe pays to keep the speed of light the same for everyone. Time stretches, space contracts, and simultaneity dissolves, all so that one number can stay constant. The speed of light is not just a speed. It is the fixed point around which space and time arrange themselves. There is something steadying in this, once the surprise settles. The universe is not careless about its limit. It rebuilds the shape of space and time, moment by moment, to protect it. The speed of light is the one thing that does not change, and everything else bends quietly to keep it so. The constancy of the speed of light took a long time to accept because it contradicts everything ordinary experience teaches. In the world of moving carts and thrown stones, speeds add and subtract in the simplest way. Walk forward on a moving train, and your speed over the ground is your walking added to the train's. It seems obvious that the same should hold for a beam of light. It does not. No matter how fast the source of a light beam moves, and no matter how fast the observer moves, the light always travels at the same speed between them. Run toward it, and it does not arrive faster. Flee from it, and it does not arrive slower. The speed stays locked, and the only way for that to be true is for time and distance themselves to adjust around it. One useful way to think of the speed of light is as a kind of exchange rate between space and time. It is the number that translates a stretch of distance into a stretch of duration and back again. Because that exchange rate is the same everywhere and for everyone, space and time are not two separate things, but two aspects of one thing, woven together so tightly that bending one bends the other. This is why a fast-moving clock runs slow. Motion through space is, in a sense, traded against motion through time. The faster a thing moves through space, the more slowly it moves through time, as measured by those it passes. At everyday speeds, the trade is far too small to notice. Near the speed of light, it becomes the dominant fact of the journey. The same trade explains why a fast-moving length grows shorter and why distant observers cannot agree on what counts as the same moment. These are not separate oddities to be memorized. They are all the same single fact, seen from different angles. The fact that the speed of light is fixed and everything else must yield to keep it so. There is a quiet grandeur in a universe arranged this way. The one thing that holds firm is not a mountain or a star or any solid object, all of which change and pass. The one thing that holds firm is a speed, a rate, a relationship. The universe is built not around a place, but around a limit, and that limit is the same in every direction, for every traveler, for all time. The constancy of the speed of light first showed itself not in any race with a beam, but in the quiet mathematics of electricity and magnetism. When those two forces were finally written down together, a single speed fell out of the equations, the speed at which their combined waves must travel. That speed was the speed of light, and remarkably, it carried no mention of who was watching or how they moved. It was simply the speed for everyone. This is why the limit feels so woven into things. It is not a property of light alone, but of the relationship between electricity, magnetism, space, and time. The same number appears whenever any of these is examined closely. It is less like the speed of a particular runner and more like a constant of the world itself, a fixed exchange between distance and duration that the universe never violates. In daily life, the trade between space and time is far too gentle to feel. The clocks of travelers and the clocks of those at rest disagree by amounts too small to measure without the finest instruments. Only when motion approaches the speed of light does the trade grow large enough to reshape a journey. But the trade is always there, beneath everything, holding the one speed fixed for all. Each time the speed of light is measured, in every way it has ever been tested, it returns the same answer. It does not drift with the seasons or vary from place to place. It does not depend on the color of the light, or the direction it travels, or the speed of whoever sends it. This unchanging sameness is part of why physicists trust it so completely. It is one of the most reliable facts we have ever found. And reliability, in the end, is what a limit offers. A universe whose deepest speed wandered would be a universe whose order could not be counted on. Because the speed of light holds so perfectly still, the rest of physics can be built upon it, layer by careful layer. The constancy that puzzled everyone at first turns out to be the very thing that makes the cosmos dependable. A universe with a fixed limit is a universe you can trust to behave the same way tomorrow as it does tonight. Hold that image as we go further. The limit is not a fragile thing that a clever engine might slip past. It is the most stubborn fact in physics, defended by the flexing of time and space themselves. To go faster than light, you would have to do more than build a better engine. You would have to unsettle the structure that holds the limit in place. If the speed of light is a limit, the natural question is why we cannot simply push harder. A rocket pushes against nothing and accelerates. Push longer and it goes faster. Why not push long enough to reach the speed of light and then a little beyond? The answer reveals something quietly profound about motion itself. As an object moves faster, it becomes harder to speed up further. It behaves as though it carries more and more inertia, more and more resistance to any change in its motion. At ordinary speeds, this effect is far too small to notice. As the object approaches the speed of light, the resistance climbs without limit. To push an object with mass all the way to the speed of light, you would need an unlimited supply of energy. Not simply a large amount. Not the output of a star, or 1,000 stars, or a galaxy of stars. You would need a truly endless amount, more than could ever exist. The closer the object comes to the speed of light, the steeper the climb, and the summit moves forever out of reach. This is why no spacecraft, no particle of matter, no living thing can ever be pushed all the way to the speed of light by ordinary acceleration. The cost is not high. It is infinite. The limit is not patrolled by a guard who might be bribed or outrun. It is protected by arithmetic that never softens. It is worth pausing on how complete this is. There is no near miss, no clever path that gets you to 99.9% and then slips across the last sliver. Every step closer to the speed of light costs more than the step before, and the final step would cost everything there is and more. The barrier is not at the speed of light. The barrier is the entire approach to it. Light itself can move at the speed of light only because light has no mass. Massless things are not pushed up to that speed. They are born moving at it, and they can move at no other speed at all. Anything with mass is forever on the slower side of the line, able to approach, but never to arrive. This already tells us something important about our question. If faster than light travel is possible at all, it cannot work by pushing an object through space faster and faster. That door is sealed, not by our weakness, but by the structure of motion. Any real path around the limit would have to avoid pushing an object through space entirely. It would have to do something else. And here the story begins to turn, because there is something else. The rule we have been describing, that nothing can be pushed through space faster than light, contains a quiet and precise word. The word is through. Nothing can move through space faster than light. Space itself was never included in that rule. That distinction may sound like wordplay, but it is not. It is the single opening through which every serious idea about faster-than-light travel must pass. The universe forbids objects from racing through space beyond the limit. It says nothing at all about how quickly space itself may stretch. The reason an object resists being pushed to the speed of light can be felt as a kind of steepening. At first, a small push produces a satisfying gain in speed. As the object goes faster, the same push produces less and less. Near the speed of light, even an enormous push produces almost nothing. The object keeps gaining, but in ever smaller slivers, and the line it climbs never quite reaches the top. This is the shape of an approach that never arrives. Mathematicians call such a line an asymptote, a curve that draws nearer and nearer to a limit without ever touching it. The speed of an accelerating object is exactly such a curve. It climbs toward the speed of light forever, closing the gap by smaller and smaller amounts, and the gap, though it shrinks without end, never closes. We have tested this, in a sense, countless times. In the great machines that whirl tiny particles to enormous speeds, the particles are pushed harder and harder, and they respond exactly as the theory predicts. They creep closer to the speed of light, and the energy required to nudge them closer still climbs without limit. They reach a fraction of a percent below the speed of light, and there they stay, no matter how much more energy is poured in. So the door marked faster engine is not merely difficult to open. It has no handle on this side at all. No fuel, no design, no patience could push an object with mass across that line, because the line is not a distance to be covered, but a cost that grows without bound. This is settled, and it has been settled for a long time. And yet the very precision of the rule contains its own quiet opening. The rule forbids motion through space beyond the speed of light. It is exact about this. It says nothing about the space itself. That single untouched word, through, is the whole of the room left to us. Everything that follows tonight lives inside it. It is a strange comfort, in a way, that the sealed door points so clearly to the only window. Because the limit is so absolute about objects moving through space, it tells us exactly where not to look. Not a faster ship, not a harder push. If there is any path at all, it must run through the behavior of space itself, and so that is where we turn. It helps to think for a moment about light itself, which moves at the limit effortlessly. Light can do this only because it carries no mass. A massless thing is not pushed up to the speed of light by any effort. It is born already moving at that speed, and it can travel at no other speed at all. The limit, for light, is not a ceiling pressed against, but the only floor it has ever stood on. Anything with mass lives on the slower side of that line, forever. It may be pushed closer and closer, but the closer it comes, the more the cost climbs, until the final sliver would demand everything there is and more. This is why every realistic dream of fast travel speaks of approaching the speed of light, never of reaching it. A fraction below is the most that mass can ever hope for. And even that fraction below would be a triumph almost beyond our means, demanding amounts of energy that dwarf anything we have ever marshaled. So the practical ceiling is lower still. The point, though, is not the difficulty of the climb, but its shape. The climb has no summit. The line is not a hard distance away. It is infinitely far, measured in the only currency that matters, which is energy. It is sometimes asked whether some future understanding might overturn all of this, might reveal the limit to be softer than it seems. Anything is possible in the long run of science. But the speed of light is not a lone rule standing by itself. It is tied to nearly everything else we know, to the order of cause and effect, to the behavior of matter, to the structure of space and time. To loosen it would be to unsettle a great deal that has been tested and held. So while no honest mind closes the door forever, the door is heavier than a headline suggests. The limit has been pushed against from every side, in theory and in the laboratory, for a very long time, and it has not given. That endurance is itself a kind of evidence, quiet and accumulated, that the limit is not a temporary obstacle, but a lasting feature of the world. So we leave behind the idea of the faster engine, gently and for good. No amount of pushing will ever cross the line. The interesting question is no longer how hard we can push. The interesting question is whether space itself can be made to carry us, and that is a very different question. with a very different answer. The loophole in the speed limit is not a trick, and it is not a mistake in the rules. It is built into the structure of the universe, and we have known about it for a long time. The rule that nothing beats light applies to motion through space. Space itself is under no such obligation. Space can stretch. It can stretch slowly or quickly, and there is no limit on how fast it may grow. When space stretches between two places, those two places move apart, even though neither one is traveling through space at all. The ground between them is simply lengthening, everywhere at once. This is not a thought experiment. The universe is expanding, and that expansion is exactly this kind of stretching. The space between distant galaxies grows steadily larger, carrying them away from one another. Nearby, the effect is gentle. Across enormous distances, it adds up into something remarkable. Beyond a certain distance, galaxies are carried away from us faster than light. Their separation from us increases more quickly than a beam of light could close it. And yet no rule is broken, because those galaxies are not moving through space at impossible speeds. They sit quietly in their own neighborhoods. It is the space between us and them that is growing, and space may grow as fast as it likes. Picture a sheet of soft rubber with two small marks upon it. A crawling insect can move across the rubber only so quickly. That is the speed limit. But if you take the sheet itself and stretch it, the two marks can be carried apart faster than any insect could ever crawl, without either mark moving across the rubber at all. The marks stay still. The sheet does the separating. The universe stretches its rubber sheet all the time, on the largest scales, without any effort from us. This is the loophole. Motion through space is capped at the speed of light. The stretching of space itself has no cap. And once you notice that gap between the two, a quiet possibility opens. The possibility from which every warp drive idea grows. The thought is this: what if a spacecraft did not try to move through space at all? What if, instead of pushing itself forward against the limit, it let space carry it? What if the space ahead of the ship could be made to contract, drawing the destination nearer, while the space behind it expanded, pushing the origin away? Such a ship would not be racing through its surroundings. It would be sitting still inside a patch of space, and that patch of space would be doing the traveling. The local speed limit would never be touched, because nothing inside the patch would be moving through space faster than light. And yet the ship could arrive sooner than a beam of light, crossing the same distance the ordinary way. This is the central idea, and it is worth holding gently for a moment, because it is genuinely elegant. The warp drive is not a faster engine. It is a different idea about what traveling even means. Instead of crossing the distance, you reshape it, shortening the road ahead and lengthening the road behind. The expansion of space is one of the most firmly established facts in all of science, and it is worth dwelling on because it is the ground the warp drive stands upon. Across the universe, the distances between widely separated galaxies are growing. Not because the galaxies are flying apart through space, but because the space between them is steadily lengthening, everywhere, all at once. Close to home, this stretching is far too gentle to notice. Within a galaxy, gravity holds everything together, and the expansion has no grip. It is only across the enormous gaps between galaxies, where nothing holds them close, that the lengthening of space adds up into real motion. And there, added over distances almost beyond imagining, it grows large. At a great enough distance, the stretching carries galaxies away from us faster than light could ever travel toward us. The light those galaxies send out now will never reach us, because the space it must cross is growing faster than the light can cover it. There is a horizon set by this, beyond which the universe is permanently out of contact. Not because anything there is moving quickly, but because the road itself keeps growing. This is the clearest proof that the speed limit applies to motion through space and not to space itself. Those distant galaxies break no rule. They sit calmly in their own regions, drifting slowly through their local space, while the gulf between us widens past the speed of light. The universe does this constantly, on the largest scale, without strain. The rubber sheet image deserves a second look because it carries the whole idea. Two marks on a stretching sheet are carried apart, not by crawling, but by the growth of the sheet beneath them. Now imagine you could stretch the sheet not everywhere, but only in a small region just behind a single mark, while gathering it up just ahead. That mark would be carried forward across the sheet, without ever crawling at all. That gathered region, moving across the sheet and carrying its passenger along, is the warp bubble in its simplest form. The universe already knows how to stretch space. The only question the warp drive asks is whether that same stretching could be shaped, deliberately and locally, into a moving pocket that carries a ship. The principle is borrowed directly from what the cosmos does on its own. The horizon set by the expansion of space is a calm thing to contemplate. Beyond a certain distance, galaxies recede from us faster than their light can travel toward us, and so their light, sent out now, will never arrive. They are not gone. They are not moving strangely. They are simply on the far side of a growing distance, carried away by the lengthening of space itself. This horizon proves, as plainly as anything can, that the speed limit governs motion through space, and not the stretching of space. Those distant galaxies break no law as they are carried past the speed of light, because nothing there is traveling. The road between us is growing, and a growing road may lengthen as fast as it pleases. The cosmos does this everywhere, gently and without effort. It is from this calm, established fact that the entire warp idea takes its courage. If space can carry whole galaxies apart faster than light, perhaps a small, shaped piece of space could carry a single ship forward in the same way. The principle is borrowed directly from the universe's own behavior. The only question, the one that fills the rest of tonight, is whether we could ever shape such a piece on purpose. There is something restful in the thought that the universe stretches space so freely on its own. The expansion asks nothing of anyone. It simply happens, everywhere, all the time, carrying the distant galaxies apart with no effort and no strain. The grandest motion in the cosmos is also the gentlest, a slow and even lengthening that no one has to drive. The warp drive is, in a sense, only the wish to borrow this gentleness and aim it. To take the stretching the universe does without thinking and gather it, deliberately, around a single ship. The wish is understandable, even lovely. Whether it can ever be granted is the long question, but the thing it reaches for is real, and the universe performs it endlessly on the largest scale. It is a quiet marvel that the loophole exists at all. The universe might have forbidden every form of faster-than-light separation, motion, and stretching alike, and left no opening whatsoever. Instead, it draws a careful line. Objects through space are held below the limit. Space itself is free. That the line falls exactly there, and not somewhere stricter, is what gives the warp idea its small foothold of hope, and what makes the rest of the story worth telling. Whether such a thing could ever truly be built is the question that fills the rest of this night. But the seed of it is real, and it rests on something the universe genuinely does. Space can move faster than light. The only question is whether we could ever persuade a small patch of it to carry us along. The warp drive is one of the few ideas borrowed from imagination that turned out to have a real description inside the established theory of gravity. It is not a loophole someone invented to dodge the rules. It is a genuine solution, written in the same mathematics that describes orbits, the bending of starlight, and the expansion of the universe itself. In this picture, a region of space is shaped into a bubble. Inside the bubble, space is flat and calm. A ship resting there feels no push, no pull, no strain, no sense of motion at all. The bubble is a pocket of stillness, and the ship floats within it as though parked in the quietest harbor imaginable. Just behind the bubble, space expands. Just ahead of it, space contracts. The expansion behind and the contraction ahead work together, and the combined effect carries the whole bubble forward. The ship is not driven through space. It is carried by the reshaping of space around it, like a leaf resting on a wave that moves while the leaf stays still. Because the ship never moves through its own local space, it never needs to be accelerated toward the speed of light. The infinite cost we met earlier never arrives, because no object is being pushed against the limit. The crew feel perfectly at rest the entire time. From inside, there is no rushing wind, no crushing force, no sensation of speed. There is only stillness, and outside the window, the slow rearrangement of the stars. This is the part of the warp drive that the headlines describe correctly, and it is genuinely remarkable. In the pure geometry of curved space, the idea holds together. You can write down the shape of such a bubble. You can describe how it would move. The mathematics does not object to the bubble itself. The bubble is allowed. The appeal of the idea is easy to feel. There is no need for unlimited fuel to reach impossible speeds. There is no crushing force on the travelers, because inside the bubble space is flat and the ship is at rest. There is no violation of the local speed limit, because nothing within the bubble outruns light through its own surroundings. And the journey could, in principle, be quicker than light crossing the open distance the ordinary way. For a moment, it can seem that the problem is solved, that the universe has left a door unlocked after all. The geometry permits a bubble. The bubble permits a journey. The journey breaks no local rule. If geometry were the whole of the theory of gravity, the story might end here, in triumph. But geometry is only one half of the theory. The shape of space is one side of a balance. On the other side stands the matter and energy that produce that shape. The theory of gravity is, at its core, a relationship between the two. The curvature of space on one side and the matter and energy that cause it on the other. So, the geometry of the bubble is not the final word. It is only the question. The geometry tells us what shape space must take. The other half of the theory then asks the harder question. What kind of matter and energy would be needed to bend space into that shape? And is such matter and energy something the universe actually contains? The stillness inside the bubble is the part that most rewards slow attention. A spacecraft pushed to great speed the ordinary way would subject its crew to enormous forces, pressing them back, straining everything aboard. The warp bubble does none of this. Because the ship is not accelerating through space, but resting in a pocket of flat space that is itself being carried, the crew feel nothing at all. No weight, no pressure, no sense of motion. From inside, there would be no way to tell, by feel alone, that any journey was happening. The cabin would be as quiet and steady as a room that never moved. Only the view outside would betray the truth, the slow rearrangement of the stars as the bubble carried its calm interior across enormous distances. that traveling would belong entirely to the space around them, never to their bodies. The image of a surfer carried by a wave is often used here, and it is a fair one. A surfer does not swim across the ocean. The surfer rests on a moving slope of water, and the slope does the work. The wave can travel far faster than the surfer could ever swim, and the surfer feels only a smooth, steady glide. The warp bubble is a wave in the shape of space, and the ship is the surfer at rest upon it. All of this is permitted by the geometry. You can write the shape of the bubble down. You can describe how the space within it stays flat, while the space around it bends. You can show that a ship at the center would feel no force. None of this strains the mathematics of curved space. The bubble, as a shape, is allowed, and that fact alone is genuinely worth pausing over. But the theory of gravity has always had two halves that must agree. One half describes the shape of space, the curving, and the flatness, and the bending. The other half describes the matter and energy that cause that shape. The two are bound together by a single relationship, and neither half is free to do as it pleases without the other. So the bubble's lovely geometry is only the first half of the question. The shape is allowed. The next half asks what would be needed to produce it. What arrangement of matter and energy could bend space into a moving pocket of flatness? And it is in that second half, the half about substance rather than shape, that the entire dream meets its quiet and stubborn obstacle. The bubble's deepest charm is that it asks nothing impossible of the ship itself. The ship does not need engines of unimaginable power. It does not need to survive forces that would crush any structure. It needs only to rest, quietly, at the center of a pocket of flat space, while the geometry around it does every bit of the traveling. The burden is shifted entirely from the vehicle to the space. Inside that pocket, the ordinary rules of physics carry on undisturbed. Clocks tick normally. Objects fall and float as they always would. The crew could move about a cabin that feels perfectly still, with no sense that anything outside is changing at all. The strangeness lives entirely at the walls of the bubble, where space is being reshaped, and not in the calm interior where the travelers rest. This separation between the still interior and the reshaping walls is lovely, and it is also a hint of trouble to come. For a bubble moving faster than light, the calm interior would be cut off from its own racing walls, unable to send any signal forward to them. The same flatness that keeps the crew comfortable would keep them powerless over the very thing carrying them. But that is a thread for later. For now, the interior is simply beautifully calm. The more one studies the bubble, the more its beauty and its difficulty seem to be the same thing. The very feature that makes it gentle for the crew, the perfect flatness of the interior, is also what would cut them off from its faster-than-light walls. The very feature that lets it outrun light, the carrying of space itself, is what demands the impossible substance. Its grace and its obstacle are not separate. They are one design, seen in two lights. This is often how the most elegant ideas in physics reveal their limits. They are not refuted by some clumsy flaw bolted on from outside. They are limited from within by the same logic that makes them beautiful. The warp bubble is a clear example. Follow its elegance far enough, and the elegance itself points to the wall. That is where the trouble begins, and it is a quiet kind of trouble, the sort that does not shout, but simply will not move. The bubble is allowed to exist as a shape. The question is whether anything in the universe could ever build it. And to answer that, we have to ask what the warp bubble would truly cost. The theory of gravity links the shape of space to the matter and energy within it. arrange matter and energy in a certain way, and space curves in response. The sun curves the space around it, and the planets follow that curve. A dense, collapsed star curves space so strongly that not even light escapes. In every case, the matter comes first, and the curvature follows. This relationship can be read in either direction. You can place matter and ask how space will curve. Or you can demand a particular curvature and ask what matter would be needed to produce it. For the warp drive, we run the theory the second way. We demand the shape of the bubble, and we ask the theory to tell us what would be required to make space take that shape. The answer is the central obstacle of the entire subject, and it does not soften with time. To contract space ahead of the bubble and expand it behind, in the precise way the warp geometry requires, you would need a region filled with negative energy. Not low energy. Not cheap energy. Energy whose density, measured by a passing observer, is less than nothing at all. This is a strange phrase, and it deserves to be said slowly. Ordinary matter has positive energy and gravitates in the familiar way, drawing things inward. The warp bubble needs the opposite. It needs a kind of substance whose presence pushes space outward rather than pulling it inward. A substance that, in gravitational terms, weighs less than empty space itself. Such a thing is usually called exotic matter. The word exotic is doing gentle, important work there. It does not mean rare, or costly, or hard to obtain. It means that, as far as anyone has ever observed, bulk matter with sustained negative energy density does not exist anywhere in nature. Everything we have ever weighed, every form of matter, and every kind of light carries positive energy. The warp drive does not ask for a great deal of an ordinary thing. It asks for a thing that may not be a thing. This is the single most important point in the whole story, and it is the one most often lost in a headline. The faster-than-light warp drive does not fail because it needs too much ordinary fuel. It fails because it needs a kind of fuel that has never been shown to exist in the amounts required. The obstacle is not the size of the tank. The obstacle is what the tank would have to be filled with. The earliest versions of the warp drive made the difficulty look complete in a second way as well. The amount of negative energy they demanded was not merely exotic, but enormous. By some early reckonings, the bubble would need more negative energy than the total positive energy of everything in the visible universe, all of it gathered into a thin shell wrapped around the ship. Consider what that means. Two impossibilities, stacked one upon the other. A substance that does not appear to exist, gathered in a quantity larger than the universe seems to contain. It was, in those first versions, not a hard problem, but a doubly closed one, shut by the nature of the matter and shut again by the scale of it. Later work improved this picture a great deal. By reshaping the bubble, by making its walls thinner and its geometry cleverer, theorists brought the required amount down by enormous factors. What once needed more than a universe could be reduced, in the mathematics, to something far smaller. This was real progress, and it is often what a fresh announcement is reporting. The relationship at the center of the theory of gravity can be said simply: matter tells space how to curve, and space tells matter how to move. The two are never apart. Wherever there is curvature, some matter or energy is causing it. Wherever matter and energy gather, space curves in response. This is the deal the universe runs on, and it has never once been seen to fail. To build the warp bubble, we read the deal in reverse. We hold up the shape we want, the pocket of flat space with its contracting front and expanding rear, and we ask the theory what must be present to produce it. The theory answers without hesitation, and its answer is the obstacle that has stood at the center of this subject from the beginning. The answer is negative energy. To bend space the way the bubble demands, there must be a region where the energy density, as measured by a passing observer, is less than that of empty space. Less than zero. A region that, gravitationally, pushes outward, where all ordinary matter pulls inward. This is not a small adjustment to familiar matter. It is its opposite. Everything we have ever encountered carries positive energy. Every stone, every star, every breath of gas between the stars, every ray of light, all of it gravitates in the same inward direction. Nowhere in all our looking have we found bulk matter that weighs less than nothing. The warp drive does not ask for a great deal of an ordinary substance. It asks for a substance whose very existence remains in question. And in the earliest descriptions, it asked for an immense amount of it. The negative energy required to wrap a ship in a bubble was reckoned, at first, to exceed the total positive energy of everything in the visible universe. The dream needed a substance that may not exist, gathered in a quantity larger than the cosmos appears to hold. It was, at the start, shut twice over. Cleverer geometry softened the second of those problems considerably. By thinning the walls of the bubble and refining its shape, the required amount of negative energy was brought down by staggering factors, from more than a universe to something far more modest in the equations. This is genuine progress, and it is often exactly what a fresh announcement describes. But it leaves the first problem entirely intact. Less negative energy is still negative energy, and the question of whether such a thing can exist in bulk has never gone away. To feel the obstacle properly, it helps to recall that gravity, in the modern picture, is not a force pulling across empty space, but the shape of space and time themselves. A planet curves the space around it, and other things follow that curve. There is no invisible cord tugging the moon. There is only curved space, and the moon coasting along the lowest path through it. Every kind of curvature we have ever seen is caused by positive energy, and positive energy curves space in a way that draws things together. The warp bubble needs a curvature of the opposite kind, one that pushes space apart, and only negative energy can produce it. This is not a matter of more or less. It is a matter of a sign, of a direction, that all known matter has, and that the bubble would need to reverse. That is why the cleverest refinements, the ones that shrink the amount of negative energy required, can never reach zero for a faster-than-light bubble. They can thin the shell, sculpt the walls, and lower the quantity by enormous factors. But the sign cannot be changed. A true warp bubble needs the outward push, and the outward push needs negative energy, and so the core of the obstacle remains exactly where it began. It is worth holding clearly that the obstacle is not a failure of cleverness. Generations of careful thought have gone into the warp drive, refining its shape, lowering its costs, searching every corner of the mathematics for a way through. The obstacle has survived all of it. That survival is not a sign that we have not tried hard enough. It is a sign that the obstacle is real. And there is a strange dignity in an obstacle that cannot be clevernessed away. It tells us we have reached something genuine, a true edge of what the universe allows, rather than a temporary limit of our imagination. The need for negative energy is not a puzzle waiting for a smarter solution. It appears to be a fact, as solid as the speed limit it serves. But smaller is not the same as zero. Reduced is not the same as achievable. The walls of the bubble could be made thinner, the quantity of exotic matter brought down, and still, the hard center of the problem would remain untouched. For a true faster-than-light crossing, the bubble would still need negative energy. And whether the universe will ever permit negative energy in the amount required is the next quiet question we must face. It would be too simple to say that negative energy is purely imaginary, a thing that exists only in equations. The honest picture is gentler and more interesting than that. In tiny, fleeting amounts, under tightly controlled conditions, nature does seem to allow something very much like it. Understanding exactly how much and for how long is the key to the whole question. In the modern description of empty space, the vacuum is not truly empty. What we call empty space hums with restless fields that can never be entirely still. There is always a faint, irreducible activity, a quiet trembling that no amount of cooling or shielding can switch off. This trembling carries a certain baseline of energy, and that baseline is what we usually call nothing. Under special arrangements, that baseline can be coaxed lower. The most familiar example involves two smooth plates placed extremely close together. Between the plates, certain patterns of the field are excluded, and the energy in the gap ends up slightly lower than the energy in the space outside. The plates are gently pushed toward one another by the difference, and that push has been measured. In the gap between those plates, the energy density dips below the ordinary vacuum, below, in effect, nothing at all. There are other arrangements too, where the quantum vacuum can be squeezed so that the energy in one place dips negative, balanced by an increase somewhere close beside it. These effects are real, and they are measurable. They prove that negative energy density is not forbidden in principle. This is the seed of truth at the bottom of every warp story, and it is worth honoring rather than dismissing. The door is not bolted shut. The universe does permit a whisper of negative energy. If the door were entirely sealed, the warp drive would be a closed case, and there would be nothing left to discuss. The door is open. It is simply held open by the width of a hair. The trouble is that nature seems to police negative energy with remarkable strictness. The very same rules that allow a little of it appear to forbid a great deal of it. There are firm constraints, sometimes described as quantum inequalities, that govern how much negative energy may be gathered and for how long. They are not arbitrary. They seem to be a steady feature of how the quantum world is built. The constraints say something like this: you may borrow negative energy, but only a small amount, and only for a short time. The more you borrow, the faster you must return it, and you must return it with an even larger surplus of positive energy pressed close beside it. Negative energy comes always paired with a debt, and the debt comes due quickly. A warp drive needs the exact opposite of a fleeting whisper. It needs a large amount of negative energy, held steadily in place for as long as the journey lasts, shaped precisely around the ship. Every attempt to take the tiny allowed effect and scale it up to that size runs into the same quiet refusal. The amount that is permitted and the amount that is needed are separated by an enormous gulf. The image to hold is of a careful lender. The universe will lend you a single coin of negative energy and ask for it back within the hour with interest. It will never offer the fortune, and it will never offer the long loan that a warp bubble would require. This is not the lender being cruel. It appears to be a rule written into the foundations, as firm as the speed limit itself. To understand why a little negative energy is allowed, it helps to sit with the strange truth that empty space is not empty. Strip a region of all matter, all light, all heat, cool it as far as it can be cooled, and a faint activity remains. The fields that fill the universe can never be perfectly still. There is always a low, irreducible trembling, And that trembling sets the baseline we call nothing. Because nothing has a baseline, it becomes possible, in principle, to dip below it. If the ordinary vacuum carries a certain small energy, then a cleverly arranged region might carry slightly less, and slightly less than the vacuum is, by definition, negative. This is not a trick of bookkeeping. It is a real, if delicate, feature of how quantum fields behave, and it has been confirmed in careful experiments. The arrangement most often described involves two smooth plates held extremely close together. Between them, only certain patterns of the restless field can fit, while outside them, all patterns are free. The result is that the space between the plates holds slightly less energy than the space beyond, and the plates feel a faint push toward one another. That push has been measured, and it is real. There are other ways to reach below the baseline as well. The quantum vacuum can be squeezed, so that its trembling is quieted in one place at the cost of being stirred up in another. In the quieted place, the energy dips below nothing for a moment. These effects are subtle and small, but they are genuine, and they prove the principle. Negative energy is not forbidden outright, and yet the universe guards it with great care. The same rules that permit a whisper of negative energy forbid a shout of it. The constraints, sometimes called quantum inequalities, lay down a strict bargain. The more negative energy you gather in a place, the briefer its stay must be, and the larger the surplus of ordinary positive energy that must sit close beside it. Negative energy always arrives chaperoned, and it never stays long. This bargain is the wall between the whisper and the ship. A warp bubble does not need a flicker of negative energy lasting an instant. It needs a steady, sustained, sculpted region of it, held in place for the length of an entire journey. Every attempt to take the small permitted effect and enlarge it to that scale meets the same quiet refusal, the same chaperone, the same debt called in before the work could even begin. The careful lender is the right picture to carry away. The universe will hand you a single coin of negative energy and ask for it back within the hour, with a little extra. It will not offer the fortune. It will not offer the long loan. And a warp bubble is nothing if not a request for an enormous fortune, lent for a very long time, with no clear way to ever repay it. It is worth lingering on why the negative energy cannot simply be stored up over time. One might imagine gathering the tiny allowed amounts patiently, a little each day, until a great reserve had been built. But the universe does not permit this kind of saving. The negative energy must be paid back quickly, with interest, and it cannot be held apart from the positive surplus that always accompanies it. There is no jar in which to keep it. This is the difference between a flicker and a fixture. The permitted negative energy is a flicker, present for an instant, gone before it could be put to use, always shadowed by a larger positive presence close beside it. A warp bubble needs a fixture, a steady and sculpted region of negative energy held for the length of a journey. The universe offers the flicker freely and refuses the fixture completely. The careful accounting of all this is one of the quieter triumphs of modern physics. We did not simply fail to find a way to gather negative energy. We came to understand, through the rules themselves, why the gathering is forbidden, why the lender always calls in the loan, why the chaperone never leaves. The wall between the whisper and the ship is not ignorance. It is understanding, and understanding has shown the wall to be firm. The rationing of negative energy can feel almost deliberate, as though the universe foresaw the use we might make of it and quietly closed the path. It is not deliberate, of course. It is simply the way quantum fields and gravity fit together. But the effect is the same as if a careful hand had set the rules precisely tight enough to permit the proof and forbid the application. This is a recurring shape in the laws of physics. Again and again, a door is opened just wide enough to show that something is possible in principle, and then held just narrow enough that it can never be used to break the larger order. Negative energy is one such door. Real enough to measure, rationed enough to refuse the warp drive. The balance is exact, and it holds. So the balance comes out like this. Negative energy is real, but it is rationed. Physics allows just enough of it to prove the concept, and nowhere near enough to carry a ship between the stars. This is not a temporary gap in our engineering that a future century might close. It has the look of a built-in feature of how quantum fields and gravity fit together, as steady and as patient as everything else we have met tonight. This brings us to the modern wave of warp drive news, the work that prompts the very question this video is named after. These are real results, written seriously, resting on careful mathematics. They represent genuine progress in the subject. They also do not do what the headlines say. Holding both of those truths at once, gently and without contradiction, is the whole point of tonight. The most notable recent advances describe warp like bubbles that could be built without any negative energy at all. They use only ordinary, positive energy matter, the respectable kind that obeys every familiar rule. For decades, the warp drive was thought to demand exotic matter unavoidably, with no way around it. Showing that a warp-shaped region of space can exist using only positive energy is a real and elegant result. This is the kernel of truth on which the headlines are built, and it is worth stating clearly so that it is not lost. It really is possible, in the mathematics, to wrap a ship in a bubble of moving space using only normal matter. The bubble need not be filled with substances that may not exist. The decades-old assumption that warp drives must always demand the impossible has, in this limited sense, been gently set aside. But there is a condition attached to that result, and it is exactly the condition the headlines tend to drop. These positive energy warp solutions work only when the bubble travels slower than light. They describe a way to enclose a ship in a calm bubble of space and carry it along at some steady fraction of the speed of light, without exotic matter, a kind of warp shell for ordinary below-light travel. The moment you ask that same bubble to exceed the speed of light, the negative energy comes straight back. The exotic matter returns. The old impossibility reappears in full, exactly where it always stood. The positive energy version is real, but it is a slower-than-light vehicle. The faster-than-light version remains locked behind the same door it has always been behind. So the honest summary is this, and it is a quiet one. Researchers have shown that warp bubbles need not be pure fantasy in their slower-than-light form. You can, in the mathematics, wrap a ship in moving space using only normal matter, as long as you stay under the cosmic limit. That is a real and worthwhile discovery, and it deserves to be admired rather than dismissed. What they have not shown, what no one has shown, is a way to push such a bubble past the speed of light without the exotic, possibly impossible, negative energy that has blocked the path from the very beginning. The progress is real, and the limit is also real. The recent work made the warp drive more genuine and less fast at the same time. There is a clean way to hold the whole result. The new work pulled the warp drive down out of fantasy and into respectable, rule-obeying physics. But it did so only by keeping the bubble below the speed of light. It brought the idea closer to reality and, in the same motion, confirmed that the faster-than-light dream stays where it was. It is easy to see how the nuance falls away. A paper describes a warp drive that needs no exotic matter, and that is true. The same paper, read closely, says, "This holds only below the speed of light, and that is also true, but quieter." By the time the story has traveled a few steps from the page, the qualifier has dropped, and what remains is the dream in its boldest shape. The modern results deserve to be described with real respect, because they are clever and they are honest. For a long time, the assumption was that the warp drive must always demand exotic matter, that there was no way to shape the bubble without dipping into the forbidden well of negative energy. The recent work overturned exactly that assumption, and that is no small thing. What it showed is that a warp-shaped region of space can, in fact, be arranged using only ordinary positive energy matter. The bubble need not be built from substances that may not exist. A ship could, in the mathematics, be wrapped in a calm pocket of moving space, sourced entirely by respectable matter that obeys every familiar rule. The decades-old belief that warp drives are forever impossible was, in this careful sense, gently set aside. This is the true and worthwhile kernel inside every recent headline. It is the part that is not exaggerated. A warp bubble made of normal matter is a real result, and it moved the subject forward in a way that genuinely surprised many who study it. If the story stopped there, the excitement would be entirely earned. But the story does not stop there, and the part it leaves out is the part that matters most. These positive energy bubbles work only as long as they travel slower than light. They describe a way to carry a ship inside a pocket of moving space at some steady fraction of the speed of light without any exotic matter at all. They are warp shells for ordinary, below-light travel, and within that limit, they are genuinely allowed. The instant the same bubble is asked to cross the speed of light, the negative energy returns. The exotic matter reappears. The old impossibility settles back into place, exactly where it has always stood. The positive energy result is real, and it is a slower-than-light result. The faster-than-light dream is untouched by it, resting behind the same locked door as before. So the recent work, read honestly, did two things at once. It made the warp drive more real by showing a version that needs no impossible substance. And it confirmed, in the same motion, that this realness comes only at speeds below light. The idea was pulled down into respectable physics, and the price of that respectability was the very thing the headline promised it had escaped. There is a gentle skill worth keeping for the next time such a story arrives. Look for the small word that the headline tends to lose. Look for slower, for below, for the quiet phrase under the speed of light. It is almost always there, resting just beneath the bold claim, holding the real meaning in place. The researchers nearly always include it. It is only the retelling that lets it fall away. The honesty of the researchers is the part most worth honoring, and the part the headlines most often erase. In the careful language of the work itself, the claims are precise. A warp drive without exotic matter, yes, but at speeds below that of light. A physical, buildable bubble, yes, but a slower-than-light one. The qualifiers are not hidden. They are stated plainly by people who know exactly how much their result does and does not show. What happens next is a kind of erosion. The careful statement passes from the page into a summary, and from the summary into a headline, and at each step, a little of the precision wears away. The phrase, "below the speed of light," so central to the meaning, is the first thing to go, because it is the least exciting. By the end, only the boldest fragment survives, and the fragment says more than the science ever did. So the lesson is not to distrust the scientists, who are careful, nor even to distrust the science, which is real. The lesson is to read slowly, to look for the quiet conditions attached to every bold claim, and to remember that the most interesting truth almost always lives in the fine print rather than the title. The warp drive grew more real this way, and no less bound by the speed of light. It is natural to feel a little let down when a thrilling claim shrinks to a careful one. But there is a steadier pleasure available, the pleasure of seeing clearly. A warp bubble of ordinary matter, traveling below the speed of light, is a real and elegant piece of understanding. It is worth more, in the long run, than a bold claim that does not hold. The truth is smaller than the headline, and it lasts. And the truth keeps its shape no matter how often the headlines return. Each new announcement, read with patience, settles into the same picture. The warp drive grows a little more real and stays exactly as bound by the speed of light. There is something reassuring in that consistency, like a tide that comes in and goes out and leaves the shore where it has always been. The science did not overreach. The summary did. The researchers were careful, and their care is the part the headline cannot carry. So when the next announcement arrives, as it surely will, the gentle thing to do is to look for the qualifier, the small word slower, the quiet phrase below light speed. It is almost always there, resting just beneath the bold claim, holding the real meaning steady. Suppose, for a moment, that the energy problem was somehow solved. Suppose exotic matter could be found and shaped at will, in any amount, held as steadily as we pleased. A true faster-than-light warp drive would still face a row of further obstacles, each interesting in its own right. Together, they suggest the universe has placed more than one lock on this particular door. The first is a problem of control. A bubble moving faster than light would, by its very nature, outrun any signal sent from inside it. The ship at the center could not send a message to the leading edge of its own bubble, because the front wall would be racing ahead of anything the crew could transmit. The bubble would carry them, but they could not reach forward to touch it. This means there would be no way, from inside, to steer the bubble, to adjust its course, or to switch it off once it was moving. The very property that makes faster-than-light travel possible also makes the vehicle impossible to govern from within. A ship that cannot be stopped or turned by those aboard, it is not really transport at all. It is closer to a thrown stone, committed to its path the moment it is released. The second problem waits at the front of the bubble. As a warp bubble travels, the thin particles of gas and the scattered light that drift through space would gather against its leading wall with nowhere to escape. They would collect there across the whole journey, pressed against the front of the bubble, building into an enormous reservoir of energy that has been swept up along the way. When the bubble finally slowed and dissolved at its destination, that stored energy would be released forward, all at once, in a single intense burst. By some estimates, it would be enough to devastate whatever lay ahead. The warp drive would arrive like a flash of released energy, which is a poor way to arrive anywhere you actually wished to visit. The gentler the destination, the worse the irony. The third problem is the deepest of all, and it returns us to a thread we set down near the beginning. Anything that truly travels faster than light is, in the eyes of the theory, also a way to travel backward in time. This is not a separate, strange idea bolted onto the first. It follows directly from the same relativity that gives us the speed limit. The reasoning is quiet but firm. Because different observers slice past and future differently, a signal that outruns light for one of them can run backward in time for another. Combine two such faster-than-light steps with a change of motion between them, and you can lay out a path that loops back to its own past, a journey that returns before it ever set out. A genuine faster-than-light warp drive, then, is not merely a fast ship. It is, automatically, a machine that could let effects come before their causes. It could carry a message to a time before the message was written. And here the universe seems to grow especially careful, because a world in which effects precede their causes is a world that no longer quite holds together. Most who study this suspect the universe simply does not permit it. There is a widely held expectation, sometimes phrased as a conjecture about the protection of cause and effect, that whenever the laws seem to allow a path into the past, some other effect rises up to forbid it. A runaway gathering of energy, a quiet instability, something closes the loophole before it can ever be used. We do not yet have a complete proof, but every time a route to the past appears in the mathematics, a reason to block it appears alongside. The control problem is worth following slowly because it is so neatly self-defeating. A bubble that carries a ship faster than light moves faster than any signal the ship could send. So the crew at the center cannot reach the front of their own bubble. Any instruction they tried to send forward would never catch up to the leading wall, which is racing ahead of light itself. This means the bubble, once set in motion, could not be steered, slowed, or stopped by anyone inside it. The very feature that makes the faster-than-light journey possible severs the crew from any influence over the vehicle. A ship that cannot be turned or halted by those aboard it is not really a vehicle at all. It is a stone already thrown, its path fixed the moment it left the hand. The second obstacle gathers quietly at the front of the bubble across the whole journey. Space is not perfectly empty. Thin gas and scattered light drift through it everywhere. As the bubble travels, this thin material collects against its leading wall, unable to pass, building up over the entire trip into an enormous store of trapped energy pressed against the front. When the bubble finally slows and releases at its destination, that gathered energy would be loosed forward all at once, in a single intense discharge. By some reckonings, it would be powerful enough to scour whatever lay ahead. The warp drive would arrive not as a gentle visitor but as a forward flash of released energy, which makes it a poor way to reach any place one actually hoped to see intact. The third obstacle is the gravest, and it is woven from the same relativity that gave us the speed limit. Because observers moving differently slice past and future differently, a signal that outruns light for one of them can be seen running backward in time by another. There is no way to separate true faster-than-light travel from this consequence. The two come bound together. It follows that a genuine faster-than-light drive is, automatically, a way to send influence into the past. Combine two such journeys, with a change of motion between them, and a path can be drawn that loops back to its own beginning, arriving before it set out. A faster-than-light ship is not merely fast. It is, by its nature, a machine that could let effects come before their causes. The universe appears to guard against this with particular firmness. There is a widely held expectation that whenever the laws seem to open a path into the past, some other effect rises to seal it. A gathering of energy, a quiet instability, a refusal written into the foundations. We have no complete proof of this guard, but its fingerprints are everywhere. Every route to the past, when followed closely, meets a reason it cannot be walked. What is most telling about these further obstacles is that each one, on its own, would be enough to stop the journey. Even if the energy problem vanished, the control problem alone would make the bubble unusable, a vehicle no one aboard could steer or halt. Even if control were solved, the gathered energy at the front would make every arrival a catastrophe. The locks are not arranged in a single line to be picked one after another. Each is fatal by itself. And behind all of them stands the matter of cause and effect, which is less an obstacle than a warning written into the structure of time. A true faster-than-light drive would be, unavoidably, a way to reach into the past, and a universe that allowed that would be a universe that could no longer agree with itself about what had happened. The deepest lock is not on the engine. It is on the order of events. Taken together, these layers suggest something gentle rather than cruel. The universe has not placed a single fragile barrier in our way, the kind a clever generation might slip past. It has arranged many barriers, of many different kinds, all pointing in the same direction. That consistency is not the universe taunting us. It is the universe being, all the way down, the orderly place that it is. Set side by side, the obstacles form a kind of quiet chorus, all singing the same note. The energy that cannot be found. The vehicle that cannot be steered. The arrival that cannot be survived. The order of time that cannot be disturbed. Each speaks in its own voice, and each says the same thing. The faster-than-light path is not merely hard. It is closed, and closed in many ways at once. That manyness is itself a comfort once the wanting quiets. A single barrier might be an accident, a thing that some future age could remove. But a barrier repeated in so many independent forms is not an accident. It is the universe being consistent with itself, all the way down, declining in voice after voice to let its own order come undone. There is reassurance to take from this, rather than disappointment. The impossibility of faster-than-light travel is not a sad accident of engineering. It is tangled together with the thing that keeps the universe sane, the guarantee that causes come before effects, that the past stays settled, that the order of events holds firm for everyone, everywhere. To break the speed of light is to risk unweaving that order. The limit is the universe keeping its own story straight. The warp drive is not the only proposed route around the speed of light. It has a companion idea, just as old and just as elegant, and it is worth a calm look because it ends at the same quiet wall by a different road. That companion is the wormhole. A wormhole is a kind of shortcut sewn into the shape of space. Imagine two distant places connected not by the long road between them, but by a tunnel that joins them directly, so that stepping through the tunnel might carry you across an enormous distance in a single stride. The two ends could be separated by many light years through ordinary space, and yet lie only steps apart through the throat of the tunnel. Like the warp drive, the wormhole does not break the local speed limit. Light passing through the tunnel and a traveler passing through the tunnel both obey every usual rule along the way. Nothing inside the throat moves through its surroundings faster than light. The trick is in the shape of the connection, not in any forbidden speed. The shortcut is geometric, not a race. And like the warp drive, the wormhole is a genuine solution inside the established theory of gravity. It is not a fantasy pasted on from outside. The same mathematics that describes the curving of space around a star also permits, on paper, these tunnels that join distant regions. The wormhole is allowed to exist as a shape in exactly the way the warp bubble is allowed to exist as a shape. But a natural wormhole, left to itself, would not stay open. Ordinary matter and ordinary energy cause its throat to pinch shut, and to do so faster than anything could cross. The tunnel would collapse before a traveler reached the far side, sealing itself in the act of being used. As a doorway, it would slam closed in the instant you tried to step through. To hold the tunnel open long enough to pass, you would again need negative energy threaded through its throat. It is the very same exotic matter the warp drive requires, in the very same amounts that the universe appears unwilling to provide. The wormhole and the warp drive reach for the identical impossible substance, each in its own way, and each is refused by the same quiet rule. A traversable wormhole would also carry the same danger as the warp drive. Connect two distant places too freely with the right arrangement of motion, and you could lay out a path that loops into the past, the same time machine that haunts every true faster-than-light scheme. The universe seems to guard the wormhole exactly as it guards the warp bubble, and for exactly the same reason. So the two great shortcuts of the cosmos are not really two problems. They are one problem wearing two faces. Both stay within the local speed limit. Both depend on matter that weighs less than nothing. Both, in their faster-than-light forms, become machines for disturbing cause and effect. And both, for now, remain elegant geometry with no known way to fill it in. There is a pattern here that has run through the whole night, and it is worth naming softly. Every path toward faster-than-light travel, however different it looks at first, arrives at the same few obstacles. The need for a substance that may not exist. The strict rationing of the little that does. The shadow of cause and effect falling out of order. The roads differ. The wall at their end is the same wall. The wormhole begins as a beautiful thought. Take two places separated by an enormous distance, and instead of traveling the long road between them, join them directly with a tunnel through the shape of space. Step in at one end and step out at the other, having crossed many light years in a single stride. The far ends could be flung across a galaxy, and yet lie only a pace apart through the throat. Like the warp drive, the wormhole never breaks the local speed limit. A traveler in the tunnel moves slowly and calmly through their immediate surroundings. Light in the tunnel obeys every usual rule. The shortcut lives entirely in the shape of the connection, in the geometry, never in any forbidden speed. Nothing races. The road is simply folded so that two distant points touch. And, like the warp drive, the wormhole is a genuine solution inside the established theory of gravity. The same mathematics that bends space around a star also permits, on paper, these tunnels joining distant regions. The wormhole is allowed to exist as a shape, in exactly the way the warp bubble is allowed to exist as a shape. The geometry does not object. It is the substance that does. A natural tunnel, left to itself, would not hold open. Ordinary matter and energy cause its throat to close, and to close faster than anything could pass through. It would pinch shut in the very act of being used, sealing the traveler out at the moment of the stride. As a doorway, it is one that slams in your face the instant you reach for it. To prop the throat open long enough to cross, you would need negative energy threaded through it, the same exotic matter the warp drive requires, in the same amounts the universe seems unwilling to provide. The two greatest shortcuts ever imagined reach for the identical impossible substance. And the wormhole, like the warp bubble, would carry the shadow of time travel, the same risk of paths that loop into the past. So the two shortcuts are revealed to be one problem wearing two faces. Both keep the local speed limit. Both lean entirely on matter that weighs less than nothing. Both, in their faster-than-light forms, become machines that could disturb cause and effect. The warp drive and the wormhole set out from different starting points, and they arrive at precisely the same quiet wall. This sameness is the most telling clue of the whole night. Two of the most creative ideas physics has ever produced, pursued independently, with full seriousness, all the way to their limits, end at the identical obstacle. That tells us the obstacle does not belong to either design. It belongs to the speed of light itself, and to how completely that limit is stitched into everything else the universe does. The wormhole and the warp drive together teach a lesson that neither could teach alone. They began as entirely separate ideas, imagined by different minds for different reasons, and pursued down entirely different mathematical roads. One reshapes a moving pocket of space. The other folds two distant points together. They could hardly look less alike at the start. And yet they end in precisely the same place. Both stay within the local speed limit. Both depend on negative energy that the universe seems unwilling to supply in bulk. Both, in their faster-than-light forms, become machines that could disturb the order of cause and effect. Two roads, begun far apart, arrive at the very same quiet wall, built of the very same stones. When two independent paths lead to the same obstacle, it is a strong sign that the obstacle is no accident of either path. It belongs to something they share, and what they share is the speed of light and the order it protects. The wall is not a flaw in the warp drive, nor a flaw in the wormhole. It is the shape of the universe, showing through wherever anyone tries to cross the limit. The wormhole leaves us with the same gentle lesson the warp drive did, only doubled. Two of the boldest ideas ever imagined, pursued with full seriousness down separate roads, arrive at one wall. When that happens, the wall is telling us something about the universe rather than about. It is showing us where the world truly holds firm. And where the world holds firm is exactly at the speed of light and at the order of cause and effect that the speed of light protects. Every imagined shortcut, however ingenious, runs up against that same protected order. The shortcuts differ in their cleverness. The wall does not differ at all. It is always the same wall, and it is always whole. It is worth saying plainly that none of this makes the ideas worthless. The warp drive and the wormhole remain among the finest examples of where careful imagination can lead, and following them to their limits taught us a great deal about gravity, about energy, about the structure of time. An idea that ends at a wall is not a wasted idea. Sometimes the wall it finds is the most valuable thing it brings back. This sameness is not a failure of imagination. The warp drive and the wormhole are among the most creative ideas physics has ever produced, and both were taken seriously, and both were followed all the way to their limits. That they meet the same quiet refusal tells us the refusal is not about any one design. It is about the speed of light itself and how thoroughly it is woven into everything else. By now, a question may be forming beneath all of this. Why should the universe be so insistent? Why guard the speed of light with infinite energy, with rationed negative matter, with the protection of cause and effect, lock after lock after lock? The answer is the gentlest part of the whole story, and it changes how the limit feels. The speed of light is not really a rule about light. It is the speed at which cause and effect are allowed to travel. It is the pace at which one event may influence another, the maximum rate at which any part of the universe can reach out and touch any other part. Light happens to travel at this speed because light is massless, but the speed itself belongs to causality, not to light. Because of this, the limit is what keeps the order of events steady. A cause comes before its effect, for everyone, everywhere, no matter how they are moving. There is no observer for whom the arrow turns around, no vantage point from which effects arrive before their causes. The speed of light is the guarantee that holds this together, the rule that lets the universe agree on the difference between before and after. If anything could outrun that limit, the agreement would come apart. For some observers, the faster-than-light signal would arrive before it was sent. Effects could precede causes. A message could reach into a time that had not yet happened. And once that became possible, the universe would no longer be able to tell a single coherent story. Different observers would disagree not just on timing, but on what had happened at all. This is why the speed of light is defended so completely. It is not a fence around a field we are forbidden to enter. It is the thread that keeps the whole fabric from unraveling. The infinite energy, the rationed negative matter, the protection of cause and effect are not separate obstacles. They are the universe, again and again, in different languages, declining to let its own story fall out of order. Seen this way, the limit stops feeling like a wall and begins to feel like a kind of care. The cosmos is enormous, and it is held together by the patience of light, by the steady guarantee that no influence may arrive before its cause. The very thing that keeps us from crossing the galaxy in an afternoon is the thing that keeps the galaxy coherent at all. There is also a quieter comfort, closer to home. Because effects cannot precede their causes, the past stays settled. What has happened, and no faster-than-light message can reach back to unmake it. The order of our own days is protected by the same rule that protects the order of the stars. The night you are resting in now will stay where it is, gently behind whatever comes next. It is worth noticing how rare it is for a limit to be a source of peace. We are used to thinking of limits as frustrations, as walls between us and what we want. But this one is different. This one is the reason the universe makes sense. Remove it, and you do not gain the stars. You lose the steady order that makes there be a universe worth crossing at all. So when the next headline arrives, promising that the limit has finally been undone, it may help to remember what crossing it would actually mean. Not merely a faster ship, but a universe willing to let effects come before causes, a cosmos that no longer keeps its own story straight. The limit holds because the alternative is not freedom. The alternative is a world that no longer holds together. The deepest meaning of the speed limit is that it is not really about light at all. It is the rate at which any cause may reach any effect, the fastest that one part of the universe can ever influence another. Light travels at this speed only because light carries no mass, and so moves at the maximum the universe permits. The speed belongs to causality. Light merely keeps pace with it. This reframes everything we have met. The infinite energy to push an object to the limit, the rationing of negative matter, the guard against paths into the past, are not three separate walls. They are one principle, spoken in three languages. The universe will not let any influence outrun the order of cause and effect, and each obstacle is that single refusal seen from a different side. The reason the universe defends this so completely is that without it, the very notions of before and after would dissolve. If an influence could outrun the limit, then for some observers it would arrive before it was sent. Causes and effects would change their order depending on who watched. The universe would lose the ability to tell a single, agreed-upon story, and that loss would be far more than an inconvenience. It would be the end of coherence itself. So the limit is not a cage built around a freer world. It is the condition that makes there be a coherent world at all. A cosmos in which causes reliably precede effects is a cosmos that can hold together, that can have a settled past and an open future, that every observer can agree upon in the things that matter. The speed of light is the quiet keeper of that agreement. There is a personal comfort folded into this, beneath the cosmic one. Because no influence can run into the past stays settled. What has happened cannot be reached back into and unmade. The order of your own days is protected by the same rule that protects the order of the galaxies. The night you are resting in now will stay gently where it is, behind whatever tomorrow brings. It is rare for a limit to be a source of peace rather than frustration. We are used to limits as walls between us and what we want. But this one is different in kind. Remove it, and you do not win the stars. You lose the steady order that makes there be a universe worth crossing, a past worth remembering, a now worth resting in. The limit is not what stands between us and meaning. It is part of what makes meaning possible. If there is one idea to carry out of tonight, it might be this. The speed of light is the speed of cause and effect are the thread on which the whole universe is strung. Everything that happens in an order, and that order holds for everyone, everywhere, because nothing may outrun the limit that keeps it. The limit is not a wall around the world. It is the spine of the world. From this vantage, the impossibility of crossing the speed of light stops looking like a loss. To cross it would be to pull the thread, to let effects come before causes, to let the universe stop agreeing with itself about its own history. What we lose by being unable to cross is far smaller than what we keep. We keep a cosmos that makes sense, a past that stays settled, a now that can be rested in. And the now can truly be rested in. Because no influence can run backward through time, the moment you are in is safe from being unmade. The order of your night is held by the same law that holds the order of the stars, patient and unbroken. There is nothing reaching back to disturb it. The limit that keeps the galaxies coherent keeps this quiet hour coherent too. There is a way of holding all of this that turns the limit from a disappointment into a quiet companion. The speed of light is not the universe saying no to us. It is the universe keeping its promise to itself, the promise that causes will come before effects, that the past will stay settled, that events will happen in an order everyone can share. That promise is the floor beneath everything, including this restful night. And a promise kept is a thing to lean on. The same law that forbids the shortcut also guarantees the steadiness of the world. We cannot cross the speed of light, and in exchange we live in a cosmos that holds together, that does not unmake its own history, that lets a quiet hour stay quiet. It is, when seen whole, a generous exchange. Perhaps that is the gentlest way to hold the whole of tonight. The limit we cannot cross is the same limit that keeps the night from coming undone. The distance we cannot shorten is the same distance that lets the stars rest, far and untroubled, in their long, slow places. What looks at first like the universe withholding something turns out to be the universe holding everything carefully, in order, ourselves included. And the universe, as far as anyone has ever been able to tell, holds together. The speed of light keeps its place at the edge of everything, patient and unchanged, and beneath it, the order of events stays firm. That steadiness is not our prison. It is the quiet floor on which everything else, including this restful night, is allowed to stand. Now the question can be answered plainly, at the end of the long and gentle road we have traveled. Did someone find a real way to travel faster than light? No. No one has. There is no device, no tested engine, no demonstration anywhere in the world. And, more tellingly, there is no design, even on paper, that achieves a true faster-than-light crossing without calling on a kind of matter that has never been found and may not exist. What is true is softer than the headline and more interesting. The warp drive is genuine physics, not fantasy. It is a real solution inside the established theory of gravity, an elegant idea taken seriously by serious people. Negative energy is real. in tiny and rationed amounts, permitted by the same quantum rules that forbid it in bulk. And recent work has shown that warp-shaped bubbles can be built from ordinary matter as long as they stay below the speed of light. Each of these is a real and worthwhile piece of understanding. Each one moved the subject forward. None of them is a faster-than-light engine. The progress is genuine, and the destination has not changed. We understand the warp drive far better than we once did, and that better understanding has, gently and consistently, confirmed that the faster-than-light version stays out of reach. It helps to see the speed of light not as a barrier somebody built across our path, but as part of the architecture of the universe. It is the same number that keeps cause before effect, that holds the order of events steady for everyone, that lets the cosmos tell a single coherent story instead of dissolving into contradiction. To travel faster than light is not merely difficult. It would mean unstitching that order. The limit and the coherence of the universe are, as far as anyone can tell, the same fact seen from two sides. And so the stars stay far. The nearest star beyond the sun remains a journey of years, even for light itself, and far longer for anything we could build. The galaxies keep their enormous distances, turning slowly in their own time, untroubled by our wish to reach them quickly. There is something restful in that, once the wanting settles. The universe is not hiding a secret door that we have simply failed to find. It has set the distances at the size they are, and the speed of light at the speed it is, and asked us to live inside a cosmos where the far things stay far, where the past stays settled safely behind us, where causes come gently before their effects, always and for everyone. These are not constraints placed upon a smaller, freer universe. They are the shape of the only universe there is, and it is a universe that makes sense. The dream of crossing the galaxy in an afternoon is, for now, only a dream. But the reason why is the same reason the universe is orderly enough to dream in at all. There is comfort in a cosmos that keeps cause before effect, that lets the stars rest where they are, that does not need us to reach them in order to be quietly beautiful. So we leave the question where we found it, gently and without disappointment. No one has found a way past the speed of light, and the honest understanding of why has carried us somewhere better than any shortcut could. The limit is not a wall. It is the universe keeping its own story straight, holding the far things far, and holding the night you are resting in safely in its place. The speed of light keeps its place at the edge of everything. Not as a barrier raised to keep us out, but as the rule that keeps the order of things from coming undone, cause gently before effect, the distant stars resting at the distance they have always been. There is no secret door we have failed to find. There is only a cosmos the right size to make sense. It is worth saying the plain answer once more, gently, because the whole journey has earned it. No one has found a way to travel faster than light. Not a working device, not a tested engine, not even a complete design on paper that crosses the limit without leaning on a substance that has never been found. The honest verdict is no, and it is a steady, unembarrassed no. But the no is wrapped in a great deal that is genuinely true and genuinely lovely. The warp drive is real physics, an elegant solution taken seriously by serious minds. Negative energy is real, in small and rationed amounts. Warp bubbles of ordinary matter are real, as long as they keep below the speed of light. Each of these moved our understanding forward, and not one of them is a faster-than-light engine. The progress is real, and the door has stayed shut. The kindest way to hold the speed of light is not as a barrier raised against us, but as a piece of the architecture that lets the universe make sense. It is the same number that keeps cause before effect, that holds the order of events firm for everyone, that lets the cosmos tell one coherent story rather than fall into contradiction. To cross it would not simply be hard. It would mean unstitching that order. The limit and the coherence of the universe are the same fact, seen from two sides. And so the stars keep their distances, and there is rest in that once the wanting quiets. The nearest star beyond the sun stays a journey of years even for light, and far longer for anything we could build. The galaxies turn slowly in their own enormous time, in no hurry to be reached, untroubled by our wish to shorten the road. The universe is not hiding a secret door we have failed to open. It has simply set the distances at the size they are. There is comfort in a cosmos arranged this way. A universe that keeps cause before effect is a universe that holds together. A universe that lets the stars stay far is a universe whose far things remain quietly beautiful, whether or not we ever stand among them. The dream of crossing the galaxy in an afternoon is, for now, only a dream. And the reason why is the same reason there is an orderly universe to dream within at all. So we set the question down where we found it, without disappointment. The honest understanding of why the limit holds has carried us somewhere better than any shortcut could, into a clearer sense of how gently and firmly the universe is built. The speed of light keeps its place at the edge of everything, patient and unchanged, and beneath it the order of things stays whole. So the long question comes to rest, and the resting is gentle. No one has crossed the speed of light, and no honest design even shows the way, and yet the night does not end in disappointment. It ends in a clearer view of a universe that is enormous and orderly and built to hold together, with its distances set exactly where they are and its limit kept exactly where it has always been. The marvels remain far, and they remain marvels. The nearest other sun stays a journey of years for light itself. The galaxies keep turning in their unhurried time, beautiful at a distance we cannot shorten, and asking nothing of us in order to be so. There is a quiet and patient kindness in a universe that does not need to be reached in order to be worth loving. And the same limit that holds the stars far away holds this moment gently in its place. Cause stays before effect. The past stays behind you, settled and safe. The night does not need to be defended against anything reaching backward through time, because nothing can. The universe will keep its order, and its distances, and its long calm, whether or not we are awake to watch. So let the question settle, fully and without strain. No one has found a way past the speed of light, and the honest understanding of why has shown us a universe more orderly and more kind than any shortcut could have. The limit holds. The distances hold. The past stays gently behind us, and the stars stay patiently far, beautiful in their distance, asking nothing of us at all. There is nothing left to solve tonight, and nothing left to carry. The universe will keep its speed of light at the edge of everything, steady and unchanged, and beneath it, the order of things will stay whole, as it has through all the long ages before this night, and as it will through all the ages after. You can let it keep watch. You can let yourself rest. Let the question rest now. Let the stars stay where they are, far and patient, and in no hurry to be reached. Let your breathing slow, and let the enormous distances settle into something quiet and kind. The universe will keep its limit, and its order, and its long, unhurried calm, whether or not we are awake to watch it. Let the distances soften. Let your thoughts grow still. Sleep well, and good night.